Dr. Daryl Butt.
Professor Daryl Butt is currently serving as the Dean of the College of Mines and Earth Sciences at the University of Utah. His research work has focused on materials processing and performance in extreme environments, carbon sequestration, and nuclear non-proliferation policy. He is also a fellow and member of the American Ceramic Society and is a member of the Materials Research Society. Prior to joining the University of Utah, he was with the Boise State for 11 years, serving as a distinguished professor of material science and engineering and as an associate director of the Center for Advanced Energy Studies from 2007 to 2016. Professor Butt received his PhD in material science from Pennsylvania State University in 1991. He has held various academic, research and leadership positions with Ceramatic Incorporation, AP Green Industries, the University of Florida, and Los Alamos National Laboratory. Professor Daryl Butt has a remarkable record of achievements as a scientist, as an educator, a mentor, and team builder. We are honored to welcome Professor Daryl Butt.
Our guest of honor, Dr. Daryl Butt, Dean, College of Mines and Earth Sciences, the University of Utah, USA.
Thank you. Yep. Okay, thank you. First of all, let me just thank all of you for being teachers. I think it's the most important profession on earth. And as a teacher, I just have to say I'm a little bit concerned about all of you that are sitting in the back. There are some seats up front in case you want to come up. You get a better grade that way. So I'm from Utah, and I think if you were to draw a line from this point directly through the center of the earth, it would come out very close to my house. And so I traveled about half the way around the world to be here, and it's a great pleasure. I'm going to say a few words about diversity in higher education. It's something I'm very passionate about, something I believe in. And I also thought it would be a really appropriate presentation to give in Pune for a variety of reasons, not just because this is a world peace organization, but also, as many of you may know, this is where the first women's school in India was established by Savitribai Phule, whose image is right behind me, I believe, on the wall. And so diversity is something that's not only important to me, but also to the community of India and this university. My college is part of a large university. We're a small college at a university with about close to 40,000 students. And we are a college of the earth. I have about 50 faculty, tenure-track faculty, and about another 50 research faculty in my college. And we do research in 65 different countries right now. My faculty are doing research on every continent and in every ocean. And so an appreciation for diversity is really important, an understanding of how to interact with other cultures and how to leverage diversity is very important to my college. As a consequence, we have a value statement, and so there should be a PowerPoint behind me that says college values at the top. I'll just read this. We have a vision statement that says, I won't read the whole thing. It says, the college values and strives to be a campus leader in safety, continuous assessment, diversity and inclusivity, collaboration and collegiality. So we have in our strategic plan a very deliberate intent to appreciate diversity and to teach diversity and to leverage diversity. And I'll just say that to have diversity is not enough. To be diverse is not enough. You have to also understand the importance of inclusivity and how to do that properly. And so the next slide, we're a few slides behind. Maybe you could get to the next slide. I decided to experiment and use some slides. So there's at the top of this next slide, it should say millennia. One more. Next. There we go. Okay. So one of the problems that we have is that we are human beings, and that is a problem when it comes to diversity. And the reason is that our biases and our instincts to filter out information evolved over millennia, and we are biased for good reason. Our biases and our suspicion of others comes naturally to us as a protective mechanism. And that's something that we have to overcome. And so I'm going to introduce a new word. Maybe you've used it before, but the term transdisciplinarity. I don't mean interdisciplinarity. I don't mean multidisciplinarity. What I mean is transdisciplinarity. And by transdisciplinarity, what I mean is we completely break down and ignore the silos of academics. Those silos tend to paralyze us. They tend to trap us into our own disciplines, and it makes us rather ignorant of other disciplines. And so I teach classes that are transdisciplinary. I try to get my faculty to teach classes that are transdisciplinary. So I thought what I'd do is just talk about an example, because that's the easiest way to illustrate something. So I actually taught a course once on the color purple. So the entire course, believe it or not, was about the color purple. It sounds like you could probably teach about an hour's worth of material, but it turns out there's a lot to it. The science of purple, the psychology of purple, the meaning of purple in history, how you make purple, where it comes from. All of these things are very deep and very complicated subjects, as it turns out. I have this little illustration here of a butterfly, and it's kind of a nice illustration also of bias. Butterflies, believe it or not, see very differently than us. We see color in the range from about 700 nanometers to about 400 nanometers. That's the wavelength of light in the visible spectrum for humans. Butterflies see light between about the color yellow and somewhere into the ultraviolet regime. So a butterfly that is pure white to us, if you were to take it, for example, into a closet and shine a black light on it, it would have a very exotic pattern on it. In other words, what looks very boring and mundane to us, that is a white butterfly, looks very exotic and exciting to another butterfly. So butterflies see the world very, very differently than we do. For example, this little photo I have in the image of a flower. We may see a flower as being yellow, but a butterfly may see a flower as having a pattern or something to it, which sends a message to it. So as educators and as a scientist, what I do is I shine light on things so I can see things differently. And there's different ways to shine light on things. You can shine light on things, for example, with electrons or photons or X-rays and learn about a material. But you can also shine light on things by leveraging diversity and leveraging the viewpoints of other humans and taking advantage of their perspective. That's another way to shine light on things. So here's the way that I do this in the classroom. So what's really important in order to leverage diversity is to set up a game that gets everybody involved. And so one way I do this is by teaching classes on reverse engineering. And coming from a different discipline, you might use a different term than that. You might call it pathology or dissection or something else. I don't know. But reverse engineering is a term that I would use because I'm an engineer. And by reverse engineering, what I mean is the process of discovery through the analysis of structure, of function, of purpose, of operation, of provenience, of provenance. In other words, where something came from, how it was handed off or how it was made. And so that's the process of reverse engineering. So another part of the course is the following concept, and that is that proof of something, you can fill in the blank, proof of a mechanism, proof of a scientific concept, proof of a hypothesis, proof of provenience, is less like a mathematical proof than it is like a proof in a court of law. And what that means is don't be satisfied with one single piece of evidence. You need many pieces of information, and that means to use all the resources around you and all the people around you in order to solve a problem. So here's an example. So this is a painting. And we're a few slides behind. I apologize. Move forward a slide. Again, move forward. Next. 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 There we go. Okay. So this is a painting. And if I were to hand you this painting and ask you to tell me something about it, everyone in this room would approach it from a different perspective. If I said to you, I want to know how this painting was made, in other words, I want to know all the materials, I want to know the chemistry, I want to know something about the substrate that it was painted on, now it becomes a very complex problem. Some of you might want to know, for example, who painted it or where it was painted or what the style was. And some of you might recognize this as being a painting probably from the 1800s. It was probably painted by an artist from the Hudson River School, just because of the way it's got the light glowing. But you would be wrong, actually, because I'm actually the person that painted this. And thank you. I heard applause over there. Is that applause? Yeah. No, you don't have to applaud. I'm kidding. So, but the point is that I know how this painting was made. So I have this information. So I know all the materials that went into that because I made the paints myself. I made the canvas myself. I painted it in 12 layers. So I know a lot of information about this. I know how complicated it is. But if I handed this to you or to a class and I said, reverse engineer this, where would you start? How would you get this going? Who would be the leaders in the class? There's all kinds of interesting questions that would be asked. An artist would ask one question, a material scientist or a chemist would ask another. And so by bringing people together, you can gain greater understanding of things and leverage that diversity. Now, my paintings are pretty boring, so in my class, the way I do it is I get real problems for students to solve. And as I said, you got to set up the game. And this is just one example of many. I was fortunate enough to be able to get a particle of a mummy portrait, and these are fairly complicated things. So these mummy portraits, please move forward a couple of slides. Again. There we go. Okay, so this is a mummy, and there's a portrait on this, and there's about 950 of these portraits known in the world. So they're fairly precious, fairly expensive, so to speak, or valuable. And we were only able to get a tiny little particle from one of these. What was really important about this particle, though, was that it was purple. And in the times of ancient Egypt, this was around 200 AD, the color purple was something that was very precious. It was the color of royalty. And next slide. And this is a picture of the particle sort of on the lower middle left of the picture, superimposed on the picture of a human hair. So the particle was about 50 microns in diameter. So this class that I taught basically was focused on a dust particle. So we spent an entire, actually 3 semesters studying this particle and trying to reverse engineer the methods that the ancient Egyptians used to paint the color purple. Next slide. So you can kind of imagine the many questions that would be asked and all the challenges that you would have. So when I taught this class, it was a research class, and I had students from psychology, sociology, material science, philosophy, art history, visual arts, chemistry, anthropology, public policy, and art conservation, all working together on this problem together. Now, when I say transdisciplinary, what I mean is that I didn't leverage their skills or their disciplines. I let them all break down the barriers of academics and do whatever they wanted to do. So I had artists that were working in my laboratory. I had chemists that were going to the library to study the volumes of Pliny the Elder to try to understand how ancient Egyptians would have made these types of pigments. And it was an amazing experience, a very, very organic type of an experience. And what's also important about leveraging diversity is to, as a teacher, to not be in control of the students, to not be in control of the class, to let it go where it needs to go, because you have to appreciate their diversity and leverage their diversity. And if you try to control the environment, you lose all of that. And so it's extremely important to flip the classroom. I assume many of you have heard that term before. And it's not an easy thing for a teacher to do. It means giving up control of your classroom and letting the students take it over. So your job is to set up the game and then give them control of the process. Next slide. I won't go into the details of this, but this is just showing some of the things that they did. It turned out that they discovered, or I believe they proved, that this purple pigment was actually synthetic, and it was probably made from madder root. But madder root makes a red pigment, and they were able to prove that that the Egyptians probably chemically shifted the color from red to purple by adding a certain salt to it, maybe unintentionally. And so in the year 200, Egyptians were actually synthesizing the color purple. We actually didn't think the color purple had been synthesized until the 1800s, but the Egyptians were doing this almost 2,000 years ago. Next slide. So to end, the point of this is that our responsibility in academics is to help our students understand the importance of diversity. There are different ways to do this. One approach, and this is just one approach, is to use transdisciplinary experiences to bring students together to solve real problems. And I believe this leads to better decision making, improved objectivity, which leads to better science, better engineering. It leads to greater emotional intelligence, greater innovation, higher social IQ, important leadership skills. But again, diversity in and of itself doesn't work if you also don't have inclusivity. So if you have a classroom that is full of male students and female students, they don't interact, that is diversity, but it's not inclusivity. And so you have to take that diversity and you have to turn it into something different by encouraging inclusivity. And transdisciplinary experiences are one way of doing that. And this is just a next slide. Next slide. And this is just a few ideas for transdisciplinary experiences for students. The example I gave was one of art and science mixed together. You can also imagine things like driverless cars, energy transitioning, isotopes in medicine, mining engineering and history, paleoecology and entertainment arts. So you can imagine lots and lots of different ways to bring students together to solve real-life problems in a transdisciplinary environment. And then the final slide, next slide, is just an image. On the left is an image created by Da Vinci, and then on the right is an image created basically by combining microscope images of a human hair and the particle at about a 500 micron resolution. And so is it art, is it science? But the whole idea of blending art and science is something we've been doing for hundreds and hundreds of years. And I think it's something that is very important to education right now. So thank you. I'll end there.
Thank you, Dr. Daryl Butt. Thank you for sharing with us with your valuable ideas.